Welcome to your first video lesson. Yesterday we did a review on solving proportions, and I mentioned that these proportions were going to help us with what we're moving into, and that is similarity. We are going to begin looking at similarity and determining are two triangles similar, and to do that we're going to need those proportions. We're going to need to understand how we solve proportions. This is something that we can use. We may even go outside and do an actual activity on this. But how can we use proportions? Well, a building casts a shadow that is 60 feet long. So we have this building, shadow is 60 feet. How could proportions be used to find the exact height of the building without having to actually measure the height? So we're going to just label that H because we don't know how tall that building is. And I really don't want to climb up there and measure it myself. But let's say I stick a ruler in the ground that's 1 foot. And I want to the sun is hitting that ruler at the same angle that building is being hit with the sun. So it's going to create kind of a similar path of a shadow. And I notice, okay, you know what, my ruler is casting a shadow that is 3 feet long. So I have a building of H height casting a 60-foot shadow, and I have a ruler of 1 foot casting a 3-foot shadow. I could set up a proportion with those numbers. I'm going to put my height over my shadow. That's how I'm going to set up my proportions. When you set up a proportion on two similar figures, you want to make sure that you're keeping things together. So I'm going to put my heights are going to go all the way across, my shadows are going to go along the bottom. But each proportion then is going to be, the first one's going to be, if I put my height of 1 for my ruler, then the shadow is going to have to be the shadow of that ruler. So I'm going to put 1 over 3. And I'm going to set that equal to the height and shadow of my building. Well, my height is H. The shadow is 60. So now I have my proportion set up. Now I'm going to do my cross multiplication or my karate chop. And I'm going to say, okay, 60 times 1 is 60. 3 times H is 3H. To get the H alone, we're going to have to undo that multiplication by dividing. That cancels the 3 out. Then 60 divided by 3 is 20. So this building is 20 feet tall. I did it without measuring. The only thing I had to measure was a ruler shadow of 3 feet. Now you could also set your proportion up a little bit differently if you wanted to. So let's say you wanted to do your ruler on top. This pen would work, right? You want to do your ruler on top and your building on the bottom. You can do that too. So if I did my ruler on top, I put my height of my ruler, and I put my height of my building underneath that. Then I put the shadow of my ruler, which is 3, over the shadow of my building. Doing the cross multiplication, do that karate chop. You have 1 times 60 is 60, 3 times H, 3H. Again, divide by the 3. And again, you get 20 equals H. When you're setting these proportions up, you have to make sure that you're setting them together. Your ruler, if you're putting your ruler all the way across, like I did on the second example, make sure your rulers, it's the measure of your ruler all the way across, and it's the measure of your building underneath the bottom. Then make sure that if you're doing the heights stay together, rulers stay together, everything has to stay together. So look at what happens when we don't keep everything together. So I'm going to put my height of my ruler, then I'm going to put it over the shadow of my building. Then I'm going to put the height of my building over the shadow of my ruler. So I've kept the heights going across and the shadows going across, but I haven't kept each part of the proportion together. So I haven't kept the ruler together, I haven't kept the building together. Now if I do the cross multiplication for that, do my karate chop, and I multiply 3 times 1 is 3, multiply 60 times H is 60H. Then I'm dividing by 60. 3 divided by 60 is not going to give me 20. You need to make sure, always remember, keep everything together. Keep the same thing going across, keep the same thing going across the bottom, keep each part of the proportion together. So, what is the difference between congruent triangles and similar triangles? We spent time talking about congruent triangles before. We have the angle side angle, angle angle side angle side, and side 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 theorems. We were able to determine, okay, two triangles are congruent because of this. But now, how can we say two triangles are similar? What's the difference between the two? In congruent triangles, you have to have 3 pairs of congruent sides and 3 pairs of congruent angles. So your triangle, your side lengths of a triangle have to be 3, 4, 5. Your angles have to be 30, 60, 90, 30, 60, 90 for both triangles. In similar triangles, you only need 3 pairs of congruent angles. So you could have 2 triangles and both triangles have interior angles of 30, 60, 90, and one triangle has 3, 4, 5 as the side lengths, but in the second triangle, those side lengths might be 9, 12, and 15. In that case, the angles inside the triangles are similar. The sides are not congruent, so they're similar triangles, not congruent triangles. So now, which of the following triangles are similar? We have 4 triangles. We want to say, okay, which 2 of these can we say are similar? So I'm going to label each triangle 1, 2, 3, and 4 so we can easily identify them when I'm saying which triangle. It's easier to understand which one I'm talking about. So we're only given 2 angles in each of these triangles. Well, let's figure out the third angle for each triangle before we do anything else. To do that, we need to remember, what is the sum of the interior angles of a triangle? 180. Never forget that. So if we're looking at triangle 1 and we do 180 minus 81 minus 70, we get 29. Angle 2, or triangle 2, 180 minus 80 minus 29, so the third angle is going to be 71. Triangle 3, we're looking at 180 minus 70 minus 29, so that third angle is 81. And then the final triangle, triangle 4, 180 minus 81 minus 28 is 71. So now that we have all that, let's look at which 2 triangles are similar. Let's start with looking at just 1 and 2. So we have 81 and 80 right off the bat. Those are not congruent angles. We have 29 and 29 are congruent, but 70 and 71 are not. So we can simply say that, you know what, 2 is not similar to triangle 1. So let's look at the second. Let's look at 1 and 3. Well, we have 81 and 81. We have 70 and 70. We have 29 and 29. So looky there. 1 and 3 are in fact similar triangles. Let's check triangle 4 just to be sure that we might have 3 similar triangles. Well, we have 81. We have 81. That's good. But then we have 28 and 71. 28 and 71 are not congruent to 70 and 29. So angle 4 is not similar to triangle 4 is not similar to triangle 1. So triangle 1 is similar to triangle 3 because, looking back, there's 3 pairs of congruent angles. Okay, so corresponding sides of similar triangles have the same ratio. Ratio is basically a proportion, one over the other. So let's look at first these top 2 triangles. Let's look at the triangle that has sides 7, 10, and 15, and triangle that has 3.5, 5, and 7.5. Looking at the shape of those triangles, you can easily look at those and say, okay, well 3.5 corresponds to 7. So let's do 3.5 divided by 7. When you do 3.5 divided by 7, plug it into your calculator. You get 0.5, which is congruent to 1 over 2. Okay? Let's take our second set of corresponding sides. So let's look at 5 and 10. So if we did 5 over 10, plug it in, 5 divided by 10, you're still going to get 1 over 2. And then the last set of sides, you have 15 and 7.5. So if you did small over big, 7.5 divided by 15, again, 1 over 2. So those two triangles are in fact similar because they have the same ratio of sides. All three sides correspond to the second triangle sides, and they all form the same ratio. Let's look at these other two triangles. So looking at those, similar shapes. So let's start with 10.5 divided by 14. So if you do 10.5 divided by 14 in your calculator, you're going to get 0.75, which is congruent to 3 over 4. Okay, so let's look at our next set. Let's do 15 divided by 18. So if we do 15 divided by 18 and you put that into your calculator, what do you get? You get 0.83333333333. You can, if you do math enter to get the fraction, you end up with 5 over 6. Okay, so already we have two different ratios, but let's just look at the last set of sides before we say anything else. So we do 22 divided by 30. Well, if you do 22 divided by 30 in your calculator, you get 0.733333333. And you could simplify that to 11 divided by 15. So now we've looked and we've said, okay, all of these sides, we have 3 over 4, we have 5 over 6, and we have 11 over 15. So that tells us these two triangles are not similar to each other because the sides don't have the same ratio. All three sides corresponding to three sides of another triangle have to be the same ratio. So, which of the following triangles are similar to each other? These are exactly the triangles that we just saw. We just proved that this triangle is similar to this triangle and that these two triangles are not similar. Two important things to know. Two very key pieces of information. Similarity does not depend on the position of the triangle. So, you could have a triangle. Why is it doing? Hold on. You could have a triangle like that. Then you could have another triangle, if I can get it. That triangle could be like flipped. It could be turned around. But these two triangles, as long as you can say, okay, well, I know that this triangle has just kind of rotated itself, so I know that this side is going to correspond with that side. In most cases, they're going to give you an angle, so you'll be able to say, okay, well, there's my right angle, those two sides correspond. So then if I have that side, I know it corresponds to that side. That side corresponds to that side. It doesn't matter if it's flipped, if it's rotated, it does not matter if any of that. It's still going to be two similar triangles. Congruent figures are also similar, but similar figures are not necessarily congruent. So you have a congruent figure, all sides corresponding are equal, all angles corresponding are congruent to each other. You have a congruent figure. Similar figures, as long as the angles inside are congruent, then it's similar. Sides don't have to be congruent. If the sides aren't congruent, it's not a congruent figure, but it is similar. So at this point, it is time for you to look at video number 2. Video number 2 is going to go into a few more practice problems. If you're having trouble with these practice problems, make sure you either ask for help from myself, or you can even ask somebody in your group to help you. That's what your partners are there for.